Tanto non si vede che sono emozionato, vero? Dunque, siccome io non ho nessun merito per presentare il professor Chomsky, l'unica cosa che posso fare è attingere alla mia esperienza personale, e giuro che rubo al massimo 3 minuti. Quando per la prima volta io dissi da ragazzo ai miei amici che ero interessato al pensiero di Noam Chomsky, la risposta fu: quale dei due? Perché, come tutti sanno, il pensiero di Noam Chomsky si articola su almeno 2 settori. Da una parte abbiamo l'analisi dei fenomeni storici, politici e sociali, inclusa la sua militanza effettiva contro la violenza, la guerra di ogni tipo, a iniziare dalla guerra del Vietnam. E dall'altra parte quella dei fenomeni linguistici, in particolare per quanto riguarda lo studio del linguaggio. Senza le sue intuizioni originali degli anni 50 non ci sarebbero oggi né le neuroscienze del linguaggio così come le conosciamo, del quale appunto il neonato Netz qui allo IUSS è soltanto un piccolo esempio, né la teoria dell'informazione digitale. D'altronde, come rivela la Arts and Humanities Citation Index, che è un indice di citazione molto famoso, il nome di Chomsky è stato il più citato al mondo per tutti gli anni '80 e per tutto il secolo del Novecento arriva al 7° posto, appena dopo Freud e prima di Hegel. Ovviamente io non caddi nella trappola e capii subito che non c'erano 2 Chomsky, si trattava della stessa persona, soltanto che quando nell'88, a 26 anni da studente, lo conobbi, mi resi conto direttamente della profondissima ignoranza che mi aveva portato a pensare a 2 Chomsky. Bastava infatti una esperienza minima di esposizione delle sue classi per capire che di Chomsky ne esistevano 3. Mancava alla rassegna un Chomsky che hanno conosciuto tutti quelli che come me hanno avuto la fortuna di essere suoi studenti a vario titolo. In questa sala sono rappresentate almeno 3 generazioni. Il terzo Chomsky è il Chomsky che si prende a cuore l'intelligenza e i limiti di ciascuno studente, lo spinge a valorizzarsi al massimo, in assoluta totale libertà, fuori dai vincoli didattici e formali. È il Chomsky che, ponendo la propria esperienza a servizio dello studente che ha di fronte, lo tratta alla pari, senza risparmiare effetti alle volte catastrofici, ma questo lo immaginate. È il Chomsky che, parole sue, ti porta a capire il valore educativo dello stupirsi dei fatti semplici, perché solo questo è il metodo per formulare nuove domande. Domande che hanno per Chomsky sempre al centro il mistero dell'uomo e della libertà. Ecco perché accanto al politologo e allo scienziato linguista, Noam è per molti di noi semplicemente un maestro.
The great humanist and linguist Wilhelm von Humboldt once described the core property of language as infinite use of finite means. That comment has been frequently quoted, often misunderstood. There's a crucial ambiguity that could not be articulated, maybe not comprehended in his day. It didn't matter very much at the time, given the state of the art, but it's of crucial significance today, and we have to attend to it. Humboldt referred to the use of language. Investigation of that topic, the use of language, reaches far beyond the effort to understand the nature of the means that are employed when we carry out that use. The gap is enormous. You can see how great it is if you pay attention to what has been achieved in the course of the intense and productive inquiries of the past years, and what remains is shrouded in mystery that has remained impenetrable for centuries and perhaps always will, yielding some insights into the what may be essential limitations of the human capacity for understanding. By mid-20th century, the progress in mathematics and logic had provided a quite general understanding, precise understanding of how an infinite system can be characterized by finite means, rather in the way that Euclid's axioms yield proofs of an infinite number of theorems of geometry, though it's worth bearing in mind that even this classical special case was not fully clarified until about a century ago. By the 1950s, the general problem was very well understood.
Microphone closer.
Sorry. Every computer is based on these principles. And it also became possible for the first time to apply such ideas to the study of human language, and by so doing to address at least a part of Humboldt's insight. But it's important to stress only a part. The linguistic counterpart to the axioms of geometry or arithmetic would be a system of rules that determines the sound and meaning of each of the expressions of a particular language. So, for example, the expression that I'm now producing, and infinitely many others, there's clearly no limit on the length, complexity of sentences that can in principle be expressed and interpreted by a speaker of a language given sufficient time and memory, just as there's no limit on the number of the size of the numbers that a person can add in principle. But there's an immense gap separating knowledge of the rules and ability to use them in any reasonable way. If that were not the case, number theory and geometry would be trivial subjects. They would reduce to the ability to memorize a short list of rules, instead of being among the most difficult and significant, sophisticated areas of human thought, with plenty of unknown truths, maybe permanently unknown. Proving a theorem is a creative act, and the same is true at some level of the sensible use of linguistic expressions. That was the question that concerned Humboldt when he spoke of infinite use of finite means. Several centuries earlier, the same question deeply concerned Descartes, and in fact played a central role in Cartesian philosophy. We call philosophy basically science. Descartes took his main task to be to provide foundations for what we call physics, what was then called the mechanical philosophy, the founding doctrine of modern science. It held that the world is a machine, basically a machine of the kind that was being constructed by the master artisans of the day, quite remarkable machines, which stimulated the imagination of the 17th century, much as computers do today. Descartes believed that he had essentially solved this problem, but he recognized that there were phenomena that in the universe that transcended the limits of mechanical explanation. The most striking example, the one that he presented as his primary example, was in fact ordinary use of language. That is, the ability of every human, but no animal or machine, animals regarded as machines, the ability of humans to use language as in fact we all do routinely, producing expressions that are new in our experience, perhaps new in the history of the language, but that are appropriate to situations, but not caused by them, a crucial distinction, and that are independent of any detectable internal state. That is, with the internal state and the circumstances fixed, you could decide to talk about the weather or Cartesian science or any other topic. And we somehow know, though how is a mystery, which utterances are appropriate to particular situations, even though not caused by them. And in fact, the difference between appropriateness to situations and caused by situations, including internal states, that is fundamental. It establishes the difference between the divide between humans on the one hand and the rest of the universe on the other. Machines and animals, which again the Cartesians regarded as complex machines, incapable of free, independent, and creative action, as all humans are, apart from severe pathology. It could perhaps be mentioned that similar ideas lie behind the libertarian concepts that were developed by Rousseau, Humboldt, one of the founders of classical liberalism, and others. They took for granted the idea that, the Cartesian idea, that a creative capacity is at the core of human nature, and they hence concluded, quite plausibly, that any social, educational, economic, political system that represses or controls that creative capacity is fundamentally illegitimate. And from that developed the libertarian concepts that we know. The same concerns lie behind Adam Smith's very sharp critique of division of labor, far less known than the passages that one reads in school, where he extols its contributions. Much later on in Wealth of Nations, he condemns division of labor because he says it will turn human beings into the most stupid and ignorant creatures that one can imagine, and adds that in any civilized society, the state will have to intervene to prevent this atrocity that you don't read in school. It's there. And it derives from the same concepts, Cartesian concepts that entered the Enlightenment. And there's a rich resonance beyond until the present. Interesting to pursue it, but would carry us too far afield here. Well, going back to Descartes, he was a working scientist, and accordingly, to account for what lies beyond the limits of mechanism, he had to introduce a new principle, kind of creative principle. In the metaphysics of his day, that meant a new substance, res cogitans, mind. The new principle then was a second substance, and the thinking substance, which is distinct from body, physical, material, the first substance governed by mechanical principles. The scientific problem that Descartes considered, and others, Descartes and others considered, was straightforward. It was to determine the character of this newly discovered substance and to show how it interacts with the mechanical world. Now, that's the mind-body problem, as it was cast within the modern scientific revolution, of course, providing a new version to traditional problems of body and soul. The project is now commonly ridiculed as postulating a ghost in the machine, but there was nothing ridiculous about it. It was perfectly sound science. Cartesian observations about the creative aspect of language use and other free acts of will and choice. These observations are correct as far as we know, and do indeed lie beyond the bounds of mechanism, even though for reasons which were not suspected at the time. I'll come back to them. So it made quite good sense to postulate a ghost inside the human machine. And then come experimental tasks. Cartesian scientists who are not well known today, but were quite important, turned to the question of how to determine experimentally whether another creature possesses this creative capacity, possesses mind. And they designed complex experiments and concluded reasonably that if some creature could pass the hardest tests, then it would be only reasonable for us to assume that it has a mind like ours. Now, back in the 17th century, this question was taking on considerable practical and ethical significance. Europeans, of course, were just then becoming to be acquainted with strange creatures from across the sea, orangutans, Negroes, Indians, and so on. And it was quite a serious question to determine which ones had minds. Not a small question. The ones who had minds had to be saved and Christianized. I won't say what happened to them, but that was the task, very benevolent, now called humanitarian intervention. As a number of distinguished historians of philosophy have pointed out, Harry Bracken, Richard Popkin, these conceptions established at least a weak barrier against racism. The reason is that mind does not admit of degrees. You can't have half a mind. You either have a mind or you don't have a mind. No such thing as a partial mind, so you can't have the kind of racism that establishes a sharp divide between us, the ones with minds, and the others, if they pass the tests. The Cartesian tests for possession of mind bear some resemblance to a popular contemporary enterprise, determining, the way it's put, is determining whether machines can think. It's important to understand here that the term machine does not refer, say, to a computer. It refers to a program, that is a theory. A computer without a program to implement may be useful as a paperweight or something, but it has no other function. It's the program that one is talking about when you talk about the machine. The standard approach to this today is often called the Turing Test. It's derived from the imitation game that was devised by the great mathematician Alan Turing, one of the founders of the modern theory of computation, among other contributions. His imitation game was designed to determine whether a computer program can fool people into thinking that the responses it produces to queries are coming from a human being. And there are very extensive efforts to pass the Turing test. In fact, you can win a big prize if you pass it. These efforts typically overlook Turing's warning that the question whether machines can think is, in his words, too meaningless to deserve discussion, which is correct and overlooked. He did feel that the exercise might be useful, perhaps as an incentive, a challenge to develop more complex computers. And that's been more or less true. It has no other value at all. Well, while the Turing test bears some similarity to the Cartesian tests, it's a far less serious enterprise. It's worth bearing in mind that the Cartesian inquiries were pure science, sensible science. It was an effort to determine whether an object has a certain highly significant property, namely mind, kind of like a litmus test to determine acidity. The Turing test has no such significance, as Turing made quite clear and unfortunately has been overlooked. Well, while the Cartesian project was quite a sensible one, including the postulation of the ghost in the human machine, it didn't survive very long. It, in fact, collapsed within several decades in a way that was a great surprise at the time and is highly instructive for us, though often misunderstood. Isaac Newton, who studied Descartes' physics in great depth, from his notebooks, he demonstrated that it did not succeed. Descartes did not succeed in his goal of providing firm foundations for the mechanical philosophy, and far more significant, Newton showed that the failures could not be remedied. Not only is mind not governed by mechanical principles, but nothing else in the world is either. There are no machines in the sense of the early modern scientific revolution, the Galilean revolution, which is the only clear notion of machine then or now for that matter. The framework of early modern science from the time of the Galilean revolution simply could not be sustained, and with it, Cartesian physics. And that was no small discovery. The framework that was rejected, that was refuted, provided the very criterion of intelligibility, and it was the conceptual basis for abandoning traditional scholastic Aristotle-based science. Great Galilean scholar Peter Machamar observes that by adopting the mechanical philosophy, I'm quoting him, and thus initiating the modern scientific revolution, Galileo had forged a new model of intelligibility for human understanding with new criteria for coherent explanations of natural phenomena. For Galileo and his successors in the modern scientific revolution, true understanding requires a mechanical model, a device that a skilled artisan could, in principle, construct, hence would be intelligible to us. So Galileo himself rejected the traditional theories of tides, for example, because, as he put it, we cannot duplicate them by means of appropriate artificial devices. And his great successors adhered to these standards of intelligibility and explanation, all destroyed by Newton. And it was therefore quite clear why Newton's discoveries were so stridently resisted by the most prominent scientists of his day, leading to a debate that persisted long after. Christian Huygens, one of the greatest scientists of the day, described Newton's fundamental concept of attraction as, in his words, an absurdity. Leibniz charged that he was reintroducing occult ideas similar to the sympathies and antipathies of the much ridiculed scholastic science, and he was offering no physical explanation of the material world. And Newton basically agreed with that. He stated very explicitly that he could provide no physical explanation for gravity. That's actually the context of his famous statement, "I make no hypotheses." He could not find a physical explanation. Newton furthermore agreed that the notion of action at a distance, which he was postulating, is, in his words, inconceivable. It is, in his words, so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. By invoking the principle, he said, we concede that we do not understand the phenomena of the material world. And as Newton scholarship emphasizes, I'm quoting again, by understand, Newton meant what his critics meant, understand in mechanical terms of contact action, our intuitive concept of causation. Nevertheless, gravitational attraction is a fact, Newton stressed. He explained that it is necessary to invoke this absurd and mystical notion, this non-mechanical principle, to account for falling bodies, planetary motion, the tides, any of the physical phenomena that early modern science attempted to address. And for the rest of his life, he sought to discover a way around the absurdity and failed, as have his successors. The concept of mind, however, remained intact. It survived the Newtonian revolution untouched. So Newton did not exorcise the ghost as the machine, the ghost as is commonly claimed. He exorcised the machine, showed there's no machines, mind remains intact, leaves us with problems of understanding. It's also commonly believed that Newton showed that the world is a machine. That's quite the opposite. He showed that there are no machines, not the world, not anything else. However, he did show something different, namely that the world is governed by mechanical principles. Newton, by doing that, laid the basis for a very different conception of what explanation must be. The world follows rigid laws, and it's therefore mechanical in the sense of following what's now called a mechanical procedure. But that's a very different notion from machine and mechanical. It's a notion that was foreign to the founders of early modern science, Newton included, for many years later. Newton's discoveries contributed to a lowering of the goals of science, something that was already taking place through the 17th century. That is, the recognition that we must abandon the hopeless quest of showing that the world is intelligible to us. It's not. Rather, we must seek intelligible explanations, intelligible explanatory theories that will provide the best account of the workings of this unintelligible world, which remain mysterious in a very deep sense, unintelligible as Galileo and the founders of modern science understood the goals of true science. The more limited goals imposed by Newton's discoveries were not entirely new. They have roots in an earlier scientific tradition that had abandoned the search for what were called the first springs of natural motion and other natural phenomena, keeping to the more modest effort of trying to develop the best theoretical accounts that we can. One of the leading historians of philosophy, Richard Popkin, refers to this approach as the constructive skepticism formulated in detail by Mersenne and Gassendi and developed further in David Hume's mitigated skepticism, essentially the contemporary view. As Popkin describes this conception, science proceeds by doubting our abilities to find grounds for our knowledge while accepting and increasing the knowledge itself and recognizing that the secrets of nature, of things in themselves, are forever hidden from us. An approach, he says, which was to have a great history in more recent times. In fact, that's modern science. Well, as I mentioned, the ghost was left intact in Newton's discoveries, and also left intact, that means unintelligible, is the creative aspect of language use, the primary criterion for mind in experimental Cartesian philosophy. Newton himself was basically a Cartesian. He was concerned with the matter. He speculated that what he called spirit, quoting him, might be the cause of all movement in nature, including the power of moving our body by our thoughts, and the same power in other living creatures. Though how this is done and by what laws, we do not know. We cannot say, he said, that all nature is not alive. Going a step beyond, John Locke, roughly the same time, added that we cannot say that matter does not think. That's a speculation called Locke's suggestion in the history of philosophy. As Locke put it, just as God had added inconceivable effects to motion, it is not much more remote from our comprehension to conceive that God can, if he pleases, superadd a faculty of thinking. Locke found this view, in his words, repugnant to the idea of senseless matter, but held that nevertheless we cannot reject it. Basically for Newton's reasons. Newton had, after all, shown that there is no intelligible concept of matter or body or physical, so we can't dismiss the concept of thinking or living matter. Well, Locke's suggestion was, in fact, very quickly taken up right through the 18th century. David Hume concluded that motion may be, and actually is, the cause of thought and perception. Others, motion being that mysterious, unintelligible phenomenon that's the core of the physical world. Others observed, I'm quoting, that thought, which is produced in the brain, cannot exist if this organ is wanting, and there is no longer a reason to question the thesis of thinking matter. Therefore, continuing, it is necessary to consider the brain as a special organ designed especially to produce thought, just as the stomach and the intestines are designed to operate the digestion, the liver to filter bile. I'm quoting the French physiologist, philosopher Cabanis. Just as foods enter the stomach and leave it with new qualities, so impressions arrive at the brain through the nerves. They're then isolated and lacking any coherence. The organ, the brain, enters into action. It acts on them, and it sends them back, changed into ideas, which the language of physiognomy and gesture, or the signs of speech and writing, manifest outwardly. We conclude with the same certainty that the brain digests, as it were, the impressions, that is, that it organically makes the secretion of thought. A century later, Darwin put the matter succinctly. He asked rhetorically, why is thought, being a secretion of the brain, more wonderful than gravity, a property of matter? Sensible comment. It's kind of interesting to see how these ideas are treated today. The last decade of the 20th century was designated as the decade of the brain, many intensive studies. The decade concluded a decade ago with a volume of studies by distinguished brain scientists and philosophers. The volume was summarized by distinguished neuroscientist Vernon Mountcastle. He wrote that the leading thesis of these researches is that things mental, indeed minds, are emergent properties of brains, though we do not yet know how these emergences take place. The word yet is a little misleading. We may never know, no reason to believe it. Other prominent scientists and philosophers have expressed quite similar ideas in recent years, describing the same thesis as an astonishing hypothesis of the new biology, a radical new idea in the philosophy of mind, the bold assertion that mental phenomena are entirely natural, caused by the neurophysiological activities of the brain, opening the door to novel and promising inquiries, rejection of Cartesian mind dualism, and so on. All of these proposals are rather odd. They all reiterate, often in the same words, formulations from centuries ago, after the traditional mind-body problem became unformulable with the disappearance of the only coherent notion of body. Can't have a mind-body problem if you don't have bodies. For example, the conclusion of the eminent scientist, philosopher Joseph Priestley, late 18th century, that properties termed mental reduce somehow to the organical structure of the brain, Locke's suggestion essentially, a conclusion stated in different words by Hume, Darwin, many others, and a conclusion that's almost inescapable, it would seem, after the collapse of the mechanical philosophy, that is, of intelligible physics. Well, with the belated revival of ideas that were reasonably well understood centuries ago, the theory of mind can be pursued in many ways, and like other branches of science, it can be pursued with the hope of eventual unification of these endeavors, whatever form it may take. And you never know. Unification often takes quite surprising forms. The unification of chemistry and physics, for example, pretty recently, actually, in my lifetime. If you go back to the 1920s, chemistry was regarded essentially as a kind of a calculating procedure because it couldn't be reduced to physics. Even Bohr's atom was dismissed as just a calculating device, couldn't be reduced to physics. And what was said at the time is, we cannot yet reduce chemistry to physics. The word yet was proven to be wrong. It was soon shown you would never be able to reduce chemistry to physics because physics was wrong. It was only after the quantum revolution, which introduced a totally new conception of physics, that chemistry, a virtually unchanged chemistry, could be unified with physics, not reduced to it. You might bear that in mind when you think about statements about whether the mind can yet be reduced to neurophysiology. Understanding of the brain is far more primitive than understanding of physics was in the 20th century, early 20th century. So you can hope for unification, but can't predict or even reasonably expect that it'll be reduction. Well, this current enterprise renews a task that David Hume undertook when he investigated what he called the science of human nature, seeking the secret springs and principles by which the human mind is actuated in its operations, including, he said, those parts of our knowledge that are derived from the original hand of nature, what we would call now genetic endowment, without understanding it any better. This inquiry, which Hume compared in principle to Newton's, had in fact been undertaken in quite sophisticated ways by the 17th century English Neoplatonists, very interesting work that influenced Kant. In contemporary literature, the general inquiry in philosophy is called naturalization of philosophy, or sometimes epistemology naturalized, or sometimes cognitive science, but it's the classical post-Newtonian inquiry. Well, to summarize briefly, I think it's fair to conclude that the hopes and expectations of the modern scientific revolution were dashed by Newton's discoveries, leaving us with several conclusions. One conclusion is that while our cognitive faculties are vast in scope, they are nonetheless intrinsically limited. Some questions that we might like to explore may well be beyond our cognitive reach. The standards of success may again have to be lowered, as has happened before, most dramatically with the collapse of the mechanical philosophy, modern science, the hopes of modern science. Another conclusion is that the mind-body problem can be put to rest, doesn't exist. There is no realistic alternative to Locke's suggestion, thinking matter. And adopting it opens the way to studying the mind just as another branch of biology, as much as the study of the body below the neck, metaphorically speaking. A great deal has been learned in the last half century of revival of forgotten traditional concerns of the going back to the early scientific revolution and the Enlightenment. But many of the early leading questions have not been answered and may never be. It's also worth bearing in mind that this last conclusion, which is quite strongly suggested by the Newtonian revolution, was quickly understood by leading thinkers. So David Hume, apart from being a great philosopher, was a historian. He wrote a long history of England. And in his history of England, of course, there's a chapter on Isaac Newton, who he called the greatest and rarest genius that ever arose for the ornament and instruction of the species. And Hume concluded that Newton's greatest achievement was that while he seemed to draw the veil from some of the mysteries of nature, he showed at the same time the imperfections of the mechanical philosophy, and thereby restored nature's ultimate secrets to that obscurity in which they ever did and ever will remain. And others agreed. This classic 19th century history of materialism by Friedrich Lange, translated into English by Bertrand Russell, he observed that we have so accustomed ourselves to the abstract notion of forces, or rather to a notion hovering in mystic obscurity between abstraction and concrete comprehension, that we no longer find any difficulty in making one particle of matter act upon another without immediate contact through void space with no material link. And then he adds, from such ideas, the great mathematicians and physicists of the 17th century were far removed. They were genuine materialists who made immediate contact a condition of influence. And this transition, he writes, is one of the most important turning points in the history of materialism, and in fact deprives the doctrine of much, if any, significance. These conclusions are commonplace among the serious historians of science. So 50 years ago, Alexander Poiré, a great historian, observed that despite his willingness to accept the conclusion, Newton had demonstrated that a purely materialistic pattern of nature is utterly impossible, and a purely materialistic or mechanistic physics as well. Newton's mathematical physics required the admission into the body of science of incomprehensible and inexplicable facts imposed on us by empiricism, by what is observed and our conclusions from these observations. Well, these conclusions about the fundamental limits of understanding appear to be radically incompatible with the views of leading contemporary scientists and philosophers. One highly regarded very recent study, physicist David Deutsch argues forcefully that the search for explanations, which is the root of all progress and distinctively human, they said that search not only conforms to universal laws of nature, but is unbounded in scope. Progress in seeking good explanations need never come to an end. That conclusion, widely endorsed, seems to conflict with the claim of David Hume and others that Newton left a veil over fundamental mysteries of nature, restoring, in Hume's words, restoring nature's ultimate secrets to that obscurity in which they ever did and ever will remain. However, the appearance of inconsistency is deceptive and is not recognized because of their common failure to understand what happened in modern science for Lange's reasons. We've just gotten accustomed to accepting it. Like post-Newtonian science generally, Deutsch and others who speak of the unbounded ability to seek explanations have tacitly abandoned the quest for intelligibility that was the driving force of modern science, from Galileo on through Newton and beyond. The fundamental mysteries of nature may remain forever, and presumably will remain forever, as unintelligible to us as action at a distance was for Newton and the great scientists of his day, and still is to us. But Newton's explanations are quite intelligible, though they have exactly the fundamental gap that Leibniz and others recognized and that Newton accepted. They do not provide a physical basis for the explanations, nor does anything since. The goals of science have been radically lowered. There is, however, a new question that arises. Why should we assume with Deutsch and many others that the capacity for explanation is unbounded? We have to accept that we cannot understand the mysteries of nature, but is it true that the capacity for explanation is unbounded? There is a line of thinking that goes back to the great 19th century philosopher, logician Charles Sanders Peirce, and it's quite common today at Deutsch too. The line of argument holds that the Darwinian theory of evolution guarantees that result. That is, natural selection provided the intellectual capacities to solve the problems that nature poses to us, not really to solve the problems because they are permanent mysteries, but at least to provide explanations that are intelligible. There's the belief that there may be questions that are beyond our cognitive reach. That's now derided as Mysterianism, term for it, which the theory of evolution puts to rest. These, again, are very strange conclusions. The humans were not selected to develop quantum theory. Didn't do any good for hunter-gatherers, or for us, for that matter, in our lives. Darwin and his successors have sought to show something quite different, namely that humans are organic creatures, a part of the natural world, and therefore, like all other creatures, their capacities have scope and limits. That includes their cognitive capacities. And the limits of human cognitive capacities are often far weaker than those of other animals. There are birds, for example, that have a memory that vastly exceeds ours, by huge orders of magnitude, in fact. But they can't deal with the birds with very elementary numerical or, of course, linguistic problems, contrary to a lot of contemporary illusions, I should add. Just as they can't swim, they're not going to be able to add or use language any more than they can swim, and for the same reasons. The reason is that scope and limits are intrinsically related. A scope requires rich structure. Otherwise, you don't have any scope. And that same structure imposes limits. No way out of this. These things are logically related. So there's no reason to escape that humans miraculously escape these general properties of the natural world, which means that Hume's Mysterianism is just normal rationality. It may well reach beyond the necessary abandonment of the search for intelligibility that animated the modern scientific revolution. Nature's ultimate secrets presumably will remain impenetrable to our understanding, but maybe also to our search for explanations. And in fact, our cognitive limits may render us incapable of even asking the right questions. For what it's worth, those conclusions seem to me quite plausible on intellectual grounds, and also, I have to admit, rather appealing as well.